Today we're going to learn 2 more properties on top of the 3 properties we've already learned. The first one is when you are raising a power to a power. Okay? For every non-zero number a and integers m and n, if you have a raised to the m power, which is all raised to the n power, what you do is you multiply the exponents. Okay? So on a power to a power, you multiply the exponents. An example I have here is 5 to the 4th power raised to the 2nd power. What you do is you multiply the 4 times the 2, and you get 5 to the 8th power. All right? So that's one of the properties. When you have a power to a power, think of it as 2 different levels of exponents. Whereas yesterday, when we were adding the exponents, those exponents were on the same level with each other. This one is you've got one up here and then one down, then you multiply them. The next one is talking about raising a product to a power. So if you have more than one thing in a parenthesis and the entire expression is raised to, let's look at this example, ab to the n power, then what that really is a to the n power, b to the n power. You can think of it as distributing your power. You distribute it to everything within inside those parentheses. So those are the 2 new properties that we're going to deal with today, but keep in mind, we're going to have to still remember all of our other properties that we've learned so far. So let's do some examples of raising a power to a power. All right, x to the 3rd power raised to the 6th power. This is a power to a power, so we're going to multiply the 2 numbers. So 3 times 6 is going to give you x to the 18th power. All right, the next one is a to the negative 2nd power raised to the 5th power. So we got, again, a power to a power. We're going to multiply those 2 numbers, and you get a to the negative 10. But are we happy? No. We're not happy with this answer. If you've got a negative exponent, you're not done. Where is it right now? Is it in the numerator or the denominator? It's in the numerator. Where does it need to be? And if I take everything out of the numerator, what do I have left? Yeah. 1 over a to the positive 10 power. So you got to remember to move stuff. If it's got a negative exponent, it's got to move. All right, let's practice the next property. Example 2 is simplifying an expression with powers. All right, so, oh, I'm sorry, this is still the same property. Same property. So we have c to the 5th power, and then we have c to the 3rd power raised to the negative 2nd power. Now here's what's interesting about this one. This c to the 5th power has nothing to do with that negative 2. So we don't do anything with it yet. We just write it down. So we have c to the 5th. Then the next one is a power to a power. So we're going to apply that property we've learned. C cubed raised to the negative 2nd power is what? Negative 6. So you get times c to the negative 6th power. And now we have 2 powers that are on the same level with each other. So now we add them instead of multiplying. So we're going to add the 5 and the negative 6 because they have the same base. So we get c to the negative 1 power. And then again, we're not happy. We got a negative exponent. We're in the wrong place. We're going to move it to the bottom. And we get 1 over c. I could write an exponent of 1 if I want to, but do I need to write an exponent if it's positive 1? No. I don't even need to write it. You can if you want, but I'm not. So you get 1 over c. Example B sets up very similar. We have t squared, and then we have parentheses, t to the 7th power raised to the negative 2nd. That means that negative 2nd power only goes to t to the 7th. It doesn't go to t squared. So we're just going to write t squared as it is. T to the 7th power raised to the negative 2nd is t to the negative 14. Now we have 2 powers that have the same base. same level of exponents, we can just add them. So you get t to the negative 12. Yep. We need to move it to the bottom, so we get 1 over t to the 12. And that's how the power to the power property works. Now we'll look at the other property where we have to distribute a power. All right, we have 2z to the 4th power. So since the 2z is in parentheses, that 4th power goes to both things. So what this is you get 2 to the 4th times z to the 4th. Now, we can do something with the 2 to the 4th power. If we can get a number by putting it in our calculator or doing it in our heads, then we need to do that. We don't want to leave 2 to the 4th as 2 to the 4th because we can get that to what it actually is. What is 2 to the 4th power? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we get 16 times z to the 4th. All right, letter B is very similar. We have an exponent of negative 2 that needs to go to everything within inside the parentheses. So we get 4 to the negative 2nd power. Now, does anybody know what I'm going to do to this g to the 5th power? Raised to the negative 2nd power? Well, we can do this all in one step. I mean, you're right, but we can... What if we did, okay, g to the 5th, we know it's raised to negative 2. So what can I go ahead and do to the 5 and negative 2? We can get negative 10. Do you see what I'm saying? So we get g to the negative 10 power because we know that we have g to the 5th and it is raised to a power. Power to a power, you multiply. So you can go ahead and multiply and get g to the negative 10. But then we got a lot of negative exponents going on, so everything has to go to the denominator. Which means we're left with a 1 on the numerator. So we get 1 over 4 squared g to the 10. We have to go one more step, though, because we can figure out what 4 squared is. What's 4 squared? Not 8. 4 times 2 is 8. 16. So 1 over 16 g to the 10. Any questions on these examples? All right, let's look at example 4. We're going to put all these properties together into some problems here. All right, so if you look at this one, we actually have to do all the properties here together. So letter A, we have x negative 2nd power raised to the 2nd power. This is a power to a power. So our x now has an exponent of negative 4. And then in the second set of parentheses, that 4 needs to go to everything within inside that parentheses. So you get times 3 to the 4th times x to the 4th times y to the what? 8. Go ahead and multiply that 2 times 4 there. All right, now, here's what I want you to do after you do this part. I'm going to rearrange everything. I'm not going to do anything mathematically on this next step. I'm just going to rearrange and get things in the order they need to be in. Your numbers need to come out front. So I'm going to move 3 to the 4th to the front. So I'm going to have 3 to the 4th. And then I'm going to put my x's together because they're alike. So I'm just rearranging things. So I have x to the negative 4 times x to the 4 times y to the 8. So I just rearranged. Do you guys see what I did there? I just kind of did some rearranging, got everything that needs to be together. I got it together. Now, 3 to the 4th power, we can get a number 4. If we put it in our calculator or in our heads, what do we get? 81. So you get 81. Now, x to the negative 4 and x to the 4. Those exponents are on the same level, right? So we can add them. If we add negative 4 and 4, what do we get? 0. So what does that become? 1. So this right here becomes 1. But do I need to write a 1 since I already have an 81? Because 81 times 1 is still going to be 81. And then y to the 8th just has to kind of be by itself. All right, letter B. We got to take the third power to everything within inside that parentheses. So we get 6 to the third, m to the third, n to the third. So that third power goes to everything within inside that parenthesis. Now we have 5m to the negative third raised to the second power. That second power has to go to everything within inside this set of parentheses. So we're going to get 5 squared. And then m, we got negative 3 and 2. We're going to multiply those to get negative 6. Now, I'm going to rearrange everything just like I did on the last example. I've got 6 to the third. That can be up front. I'm going to move 5 squared next to it. Then I'm going to put my m's together. And then I'll put my n. So I'm just kind of rearranging, getting all my numbers together, all my like variables together. Now, 6 cubed times 5 squared. You can put that directly into your calculator and get a number. 5,400. It is 5,400. If you put it in your calculator, you will see that this right here becomes 5,400. You can do it separately if you want. You can do 6 cubed, and I think you get 216. And then 5 squared is 25. And then if you take 216 times 25, you get 5,400. So that's how we get that number. Now let's put our m's together. We have m to the third and m to the negative 6. What do those combine to get? M to the negative third power, n to the third. We are almost done with this problem. We have one more step. Yeah, we need to bring down this one. Okay. So what this turns into is 5,400 n to the third over m to the third. Any questions on any of the steps that I did in this problem? All right. We got one more example here to look at. All right. All objects, even resting ones, contain energy. A raisin has a mass of 10 to the negative third power times 3 times 10 to the 8th, all raised to the second power. That's a mouthful right there. It describes the amount of resting energy in joules the raisin contains. Okay, it's a word problem, but what is it telling us to do? Simplify the expression. So it's a big long word problem just to say, okay, hey, let's simplify this. So let's rewrite the expression right here. 10 to the negative third power, 3 times 10 raised to the 8th, all of that raised to the second power. Where do I begin? The what? Right here? Oh, well, we can't do anything with 10 to the negative 3 yet. We're just going to rewrite that. But we need to do something with this, too. It's a power. It needs to be distributed to everything within inside that parentheses. But we're still keeping the scientific notation form, okay? So we have 3 squared. What's 3 squared? 9. So we have 9 times 10. What do I do with the 8 and the 2? It's a power to a power. Power to a power. We got 2 levels. We multiply, not add, right? We multiply, so we get 16. All right, we're still multiplying here. What we do is we just combine our 10 to the negative 3 and 10 to the 16 together, okay? Our leading number is going to be 9 when we're done, okay? You can imagine this being, you know, this is just going to group with this. It's like we were rearranging a while ago. So we have 9 times 10. Now, the 16 and negative 3, they're on the same level. So this time we add them, yeah. So we get 16 and negative 3, we add those to get 13. So the answer is 9 times 10 to the 13th power. So we have now finished all of the properties on multiplication. Do we have any questions? All right. Thank you for listening.